Hey everybody, Mr. Field here, back with a quick little mini lesson on evaluating trig expressions with your calculator. Alright, so first and foremost, we know that these are going to be expressions because there is no equal sign. We will later in this course start talking about how to solve trig equations, which is kind of fun, so check that out. Anyway, so remember, essentially all we're doing here is we're going to combine our Algebra 1 skills, or PEMDAS, with our knowledge of trig expressions. And a couple other things to quickly note here. Keep in mind, most importantly, this bottom one at the bottom, right, is that there's a certain syntax, how they're writing things. So for instance, if you look at letter A, you'll notice it says 3 plus sine squared of 90. Well, when you have sine squared of 90, really what it's saying, similar to this problem up here, the sine of 30 degrees squared is really how you want to think about it, because some kids will make the mistake of saying, and the reason basically they put the squared where it is next to the sign rather than with the 90 here is because a lot of people will end up doing this. They'll just simply say, okay, I'm supposed to take 90, square it, and get a very large number, and then plug that into my calculator for the degrees, like the sine of 8100 degrees, which was not what it's saying. So that's the reason why they put the sign, the squared out front, that exponent. Alright, so what it's trying to tell you is I'm going to find what the sine of 90 degrees is first, and then take that number, that answer, and then square it. Then, of course, add the 3. So we're still following the order of operations, PEMDAS, right? But there's just that new little vernacular, or I guess you could say syntax, that I wanted to show you. So without further ado, let's hop in and do a couple of these examples. So don't freak out. It's not as scary as you think. At this point, we know. And we can evaluate, for instance, what the sine of 90 is. So again, we're supposed to take the sine of 90, we're going to do 3 plus the sine of 90 degrees, and then we're going to square that and divide by 4. That's really all that's happening here. It may look weird. Once you try a couple, it becomes pretty easy. Well, I know that sine is y, so we essentially want the y value here at 90 degrees, so it should be 1. So the sine of 90 is going to be simplified to 1, getting us 3 plus 1 squared divided by 4. Well, we know 1 squared is 1, and 1 plus 3 is 4, and 4 divided by 4 is, well, just 1. So all of that to get an answer of 1 for letter A. All right, let's move on to letter B. So we want the cotangent of 45 degrees minus the cosecant of 30 plus the secant of 45, which looks scary, right? But we're going to take 12 and times it times whatever we get for the cotangent of 45. Then we're going to subtract whatever we get. I'm going to use the unit circle or the trig toolbox. I know that your calculator can do some of this work, but you won't have it, so you're going to get practice using the unit circle or that trig toolbox to answer these questions. But again, it's 12 times whatever we get for the cotangent of 45 minus the cosecant of 30 plus whatever we get for the secant of 45 degrees. So we're simply going to use that unit circle or your trig toolbox off to the right in order to answer these questions. So we know we're at 45 degrees, so I'm automatically thinking we've got some root 2 over 2 action going on here. Now, we know that tangent is y over x. So in this case, tangent would be root 2 over 2 over itself, which, again, just simplifies to 1. Well, cotangent is the inverse, or the flip, the reciprocal, so that would be, again, root 2 over 2 over itself, or 1 over 1, which is just 1. So all of that to realize that this is just 12 times 1. And then the cosecant of 30 degrees, again, that's the cosecant is the flip of sine. So we know sine is y, so that means cosecant would be 1 over y. So, and remember, y value at 30 degrees. So I'm thinking, okay, we got the y value at 30 degrees, that's 1/2. We want the flip of that, or the reciprocal. So it should be 2 over 1, or long story short, 2. And then finally, the secant of 45 degrees, well, we're looking for the flip of cosine. We know cosine is considered x, so secant should be considered 1 over x, or the flip of whatever the cosine is. So let's just find the cosine at 45 degrees, which should be the x value. Looks like root 2 over 2. We're going to actually have to flip that. So the secant would be 1 over root 2 over 2. And remember, dividing by a fraction is the same as multiplying by the reciprocal. So we've got to do a little bit of work here and flip it, realizing that, well, 2 over root 2, we can't leave that unrationalized. So we're going to multiply by root 2 over 2 to get 2 root 2 over 2. And the last step, these 2's should cancel, becoming 1. So the answer should just be root 2, if I'm not mistaken. So long story short, we're going to do 12 times 1, which is 12, minus 2, which is going to be 10 plus root 2. And since 1 is in radical form and 1 is not, we're going to leave it in exact form. We're just going to leave it just like that, 10 plus root 2. Of course, you could get the decimal version, but we're typically going to ask for the exact form. That's it. That's as far as we can go, arithmetically. So let's try this next one. So we're going to find the sine of 0 degrees, and we're going to square it. And then notice there's nothing here, so we're assuming there's multiplication. There's no like addition or subtraction between the two terms. So we're going to times that times the tangent of 60. We're going to find that and then square it. And then we're going to add 23. Well, the sine of 0 degrees, we look at our reference, 0 degrees should be the y value, so it should be 0. So all that's going to kind of amount to nothing because we know 0 squared is just 0. And what's weird is that 0 times anything, I already know because I'm pretty good at algebra, that no matter what the tangent of 60 squared becomes, it's going to be multiplied by 0. So the answer for the first part here is going to essentially cancel out, and the answer is going to be 23. But let's actually indulge ourselves here. Tangent of 60 degrees. So the tangent of 60 degrees is going to be the y over the x, right? So it's going to be root 3 over 2 over 1/2. Again, divided by a fraction, the same as multiplying by the flip of that fraction, in this case 2 over 1. Those 2's cancel, getting us a nice, easy root 3. Now, we're going to plug that in, but as I mentioned a moment ago, it's going to go away because root 3 times 0 is just 0, and if we add 23, our answer should be just 23. So all that thought, all that work, you just realize it's just 23. All right, now let's try some in radians. Maybe I'll do 1 or 2 more and then call this because I don't want this video to get too long. So the secant to the third power. So essentially, we're going to find the secant of pi over 3, which, mind you, is, well, pi is 1/80, and divided by 3 should be 60 degrees. So we're really finding the secant of 60 degrees, and then we're going to take it to the third power, minus, on the right side, we're going to find the cotangent of pi over 4, which, if I'm not mistaken, is 45 degrees, and raise that to the third power. So, if you want to change it to degrees, you certainly could rewrite this and just say, hey, I'm finding the secant of 60 degrees to the third power, minus the cotangent of 45 degrees to the third. If that makes you more comfortable seeing it not in radian form, in degree form, certainly feel free to do that. I'm pretty confident we wouldn't have an issue with that. But typically, although some teachers, if it's given in radians, they want it in radians, but for me, I'm more flexible. So let's check it out. The secant of 60 degrees. Well, 60 degrees, right, is here. We know secant is the flip of cosine. Cosine is x. So we want to take the x value and flip it. So instead of 1/2, it's going to be 2 over 1. So we end up with 2. Then we're going to raise that to the third power, getting us 8 minus whatever we get over here. The cotangent of 45. Well, I'm thinking we're going to get 1, but let's just be sure. So cotangent, remember, is the flip of tangent. Tangent would be root 2 over 2 over itself, which becomes 1. So cotangent would be the same thing, root 2 over 2, this one, divided by the other one, and we end up getting 1. So thankfully, it's a nice, pretty answer. We end up with 1 to the third power, which is just 1. So I think our final answer is 7. So, why not? I'll do them both. Let's get it done. Who cares? Why not? All right, so let's finish the last two. So we got secant squared of theta, or sorry, 0 degrees. So we know, again, we're going to take whatever the secant of 0 is, and we're going to square that. Plus, we're going to take the cotangent of 30, and we're going to square that. And we're going to times it, times the cosecant. Notice there's no plus or minus there. So we're going to take that and find the cosecant of 60 degrees and square that. So that's really what's going on overall. So let's actually evaluate it. So the secant of 0, well, I know that that's the flip of cosine. Cosine is x. So we're looking for the x value at 0 degrees, which looks like it's 1, and we're going to flip it. It's really 1 over 1. So if we write the reciprocal, it's still just 1 over 1, or 1. So long story short, we're going to have 1 squared, if I'm not mistaken. Uh-oh, where'd my screen go? My problems disappeared. Ain't that fun? So I believe it's still 1 squared. We're having some technical difficulties here, which should just be 1. Plus cotangent of 30. Well, that's the flip of tangent at 30 degrees. Well, tangent, right, would be y over x, 1/2 over root 3 over 2. But we're going to do root 3 over 2 over 1/2, which we already did here. So we know we're going to get root 3 as our answer, or root 3 over 1. And ironically, when we square a square root, well, they're opposite operations, so we should end up with just 3, right? Not the prettiest 3 I ever drew. Let's try that again, all right? And then, of course, we have to times that times the cosecant of 60. Well, cosecant's the flip of sine. I know that sine is y. So we're going to go to 60 degrees. We're looking for the y value, which is root 3 over 2 right there at 60 degrees. And we want to do the flip of that. So the flip of root 3 over 2 would be 2 over root 3. We're then going to rationalize that, getting us 2 root 3 over 3. So to finish this off, we're going to do 1 plus, we got to do 3 times 2 root 3 over 3. Remember, PEMDAS is still a thing. What comes first, addition or multiplication, or addition subtraction versus multiplication and division? Well, multiplication comes first before addition. So these are going to cancel, and we end up with 1 plus 2 root 3, which again, we're going to leave in radical form. Now, I am not sure where I slid. Oh, there it is. Somehow I slid it all the way over. Isn't that strange? So yes, I guess I'll finish this last one off, and we'll call it a day. All right, so we're going to do the cotangent is 60 plus the secant of 30 plus, finally, the cosecant of 45 divided by the secant of 30. So last but certainly last, let's use our unit circle. Cotangent is 60. So that's going to be x over y. So we're going to have 1/2 over root 3 over 2. And we've done this before, so hopefully it goes quicker. But again, dividing by a fraction is the same as multiplying by the reciprocal. Boom. So these two should cancel to create 1, and we get 1 over root 3. At this moment, we're thinking, uh-oh, I got to rationalize this. I'm not supposed to leave the radical in the denominator. Now, I know some teachers nowadays are getting a little more lax with that, because technically that's not the wrong answer, but it's technically also not the most simplified. But listen to whatever your teacher says. But for me, I'm cool with it either. You could really leave it like this. But for these purposes, root 3 over 3 is more of a value that you see more often, so I'm going to go with that. But we end up with root 3 over 3 when we get the cotangent of 60 degrees. Plus the secant of 30. Well, secant is the flip of cosine. Cosine is x. So we're going to find the x value at 30, which is root 3 over 2, right? And we're going to flip that, which is, again, going to be 2 over root 3. So off to the side, we have 2 over root 3. Can't leave it like that. We're going to rationalize and get 2 root 3 over 3. By the way, just thinking ahead, this is really 1 root 3 over 3. Plus 2 root 3 over 3. So already these are indeed like terms. They have a common denominator. But before I add them, well, actually, you know what? Let's add them. 1 plus 2 is going to be 3 root 3 over 3. And you see it, baby. Well, see you later. 3 over 3 is just 1. So we end up with just 1 root 3 or root 3 plus whatever we get in here. So let's wrap it up, and we'll call it a day on the video. So cosecant is the opposite of sine of 45 degrees. We know... So sine is y at 45 degrees, so we're going to say root 2 over 2, and we're going to flip it, all right? Because we want the cosecant, not the sine. So it's going to be 2 over root 2. Again, we got to rationalize it. And a lot of times I just do this work off to the side. We get 2 root 2 over 2, which is just, well, root 2. So, sorry, up top, over here, we end up with root 2 on top divided by, right, this is what we got for the cosecant of 45, the secant of 30. And again, secant is the flip of cosine. Cosine is x. So we're looking for the x value of at 30 degrees, and we're going to flip it, which should be root 3 over 2, which is all the work. So we have root 3 over 2. We're going to flip it. We're going to realize we can't leave it like that. We're going to rationalize. You're going to get 2 root 3 over 3. So we should have root 2 divided by 2 root 3 over 3. Divided by a fraction is the same as multiplying by the reciprocal. So we're going to end up with root 2 over 1, which is really the part up top, times 3 over 2 root 3. Again, we're going to have to rationalize by multiplying by root 3 over root 3. So we end up with root 2 over 1 times, it's going to be 3 root 3 over, 2 times 1 is 2. Root 3 times root 3 is the root of 9. So it's really 9, sorry, the square root of 9, which is just 3 on the bottom. They cancel, woo, all that to get root 3 over 2. What a doozy. So it's root 3 plus root 3 over 2. And these are technically not like terms. I could, if I wanted to, make them like terms, but it's kind of unnecessary. So I'm just going to leave my answer like that. So obviously the last one, probably the hardest. All right. So I hope you appreciate the video. Try these practice problems. Oops. Let's go over. Try these practice problems at the bottom, and let me know if you have any questions. Thanks for listening.